Howdy, y'all. So hey, oh my gosh, we are on to a brand spanking new unit 10. Hopefully everybody got a chance to take their test on the formative um, and get all that done. And we are just going to move on to the next bit. So we have been talking a lot about a trigonometric ratio, sine, cosine, tangent, SOHCAHTOA, all that good stuff. And that is awesome as long as you have right triangles. If you don't have right triangles, that's when things get a little, well, different. So what we're going to do is we're going to explore what to do when you have a non-right triangle. Another word for that is oblique, an oblique triangle. Right? And how can you figure out different sides? Because I can't use SOHCAHTOA if I don't have a right triangle. So how do I figure out all the sides and angles and stuff? So we have two tools at our disposal. One of those tools is the law of sines, which we're going to talk about here in this little section of notes. And the other one of those tools is the law of cosines, which we're going to talk about next time. So before we do anything, I want to make sure you are going to need a calculator. You can use a scientific or a graphing. You are going to need something that has trigonometric functions on there. So make sure that you have one of those handy because it's going to be important here in a second. So before we do anything, I want to make sure that you know how to do this. So if I said the sine of x was equal to, I'm just making up stuff here. So let's just say 0.7. That is not on the unit circle, right? 0.7 is not on the unit circle. So what I could do is I could make myself a fancy right triangle like we did in the last unit. And we know that sine is opposite over hypotenuse. So we could say, if this was theta, we have 0.7 over here, we have the hypotenuse. And we could, sorry, I'm getting ahead of myself. This would be the hypotenuse is over 1. We could make that the hypotenuse. We could solve, but we're still not going to be able to find the angle right there, right? So we're going to have to use a calculator. Here's the thing. Just like all of the angles in the unit circle have a very specific sign. So the sine of 30 degrees is always going to be 1/2, no matter what. Sine of pi over 6 radians is always going to be 1/2, no matter what. Some people sat around a long, long time ago, before the internet was around, and they figured out what the sine value would be for every possible angle. And they used to, before we had calculators that memorized all this stuff, they used to literally have charts, or tables rather, and you would go through and you'd be like, okay, so the sine of 15.351 degrees is, and you would go over and find it. Luckily, now we have calculators to do all that work for us. So since this isn't going to work, we can't use our unit circle, we can't use trigonometry to find this. What I'm going to do is I'm going to say, okay, so the inverse sine of 0.7 is equal to x. And that is what I'm going to type in my calculator. So right quick, we're going to have a close and personal time. So I'm going to turn my calculator on and I'm going to go, here is the sine button right there. Boop, 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 boop. And you're going to hit second sine and then of 0.7, and I'm going to hit enter. And what I've got, let me make it to where you can see it. I hope, oh my gosh, you can't, it is so dark. You can't see that at all. Can you see it? I can't see that at all on the screen. It says 44.4. So that must mean, there it is, 44.4 tells me I'm probably in degrees. So make sure that you know whether or not you are in degrees or radians. For this unit, pretty much everything we're doing is going to be in degrees. So I know this is a big shift from radians, because we've been doing everything in radians, but pretty much everything now is going to be in degrees. So second sine 0.7, and I got 44.427. So what I can do, let me go back to my iPad, I hope. Oh, it was brave to stop in the middle of the meeting. Here we go. Yay! So what I can say based on my calculator here is that 44.427 degrees is equal to x. Booyah. Okay. So I just want to make sure you know how to do that, because you're going to have to know how to do that for much of this stuff. And yes, if you're wondering, did I get a haircut? I did. I borrowed some bzz bzz from a neighbor and took it off. I'm so aerodynamic now. Y'all, let's talk about some triangles. So I have 4 examples for you. So when we think about oblique triangles, non-right triangles, I'm just going to draw a random oblique triangle. Let's make it, it looks great. So we're going to call this A, B, C, and all of our angles are going to be capital letters. And then the side that is across from angle A, that is going to be side A. That's going to be a little a. The side across from angle B, that's going to be little b. And then the side across from angle C, all the way over there, that's going to be little c. So that's how we label these triangles, these non-right triangles. Now, for the law of sines, there are 3 cases that we can use the law of sines for. And those 3 cases are if we know an angle, a side, and an angle. Oh, let me make it capital, and an angle. So if we know 2 angles and the side between them, if that's the 3 pieces of information that we know, we can use the law of sines. If we know a side and then an angle and an angle, so if we know a side length, and then I guess I could look on here. I'm like trying to like show you in this tiny screen up here. If we know like maybe side C, and then we know angle B and angle C, we can use the law of sines for that. That would be a side angle angle, right? Let me go ahead and illustrate this one. An angle, side angle, that would be if I knew an angle, a side, and an angle. So 2 angles and a side between them, I could use the law of sines. And then the other situation that we can use a law of sines for is if we know 2 sides, side, side, and angle. You can also write angle, side, side. I'm not going to write it, because what we usually do is we abbreviate these like this. So angle, side, side turns out to spell something a little, it's just not what I want to write on my on my notes that go on the internet for everybody to see. So a side side angle means I know 2 sides and then the very, very next angle after that. So these 3 cases are when I would use the law of sines. And you might be saying to yourself, what the heck is the law of sines? What a great question. Let me tell you what the law of sines is. I'm going to tell you the formula, and this is one of my favorite formulas because it's super, super easy to remember. The law of sines is the following. The sine of angle A divided by side A, the length of side A, is equal to the sine of angle B divided by side B. Those 2 ratios are equal to each other. Not only that, but both of those are equal to the sine of angle C divided by side C. Hot dog. So I can move those around. I can mix those. If you wanted to flip them, if you wanted to have them the other way, like side A over sine of A is equal to side B over sine of B is equal to side C over sine of C, you could do that too. They mean the same exact thing. So that is a law of sines. That is the formula for the law of sines. So let me give you, let's just dive right into an example. I have a couple of fun examples here Boop, 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 boop. So let's do this. I'm going to say, hey, I have, oh golly, let's say I have angle A is 40 degrees, angle B is 60 degrees, and side A is equal to 4. And usually, man, what I should do, I'm going to give you some units there. Let's say 4 inches. Everything's nicer with units. So what I want you to do when you're solving these is to go ahead and sketch this triangle. You do not have to draw it to scale. I understand it's not going to be drawn to scale. That's fine. But I want you to be able to visualize what are the opposite sides and angles that you're dealing with, right? So let's go ahead and get down here, and we're just going to draw this triangle. And then let's say this is side A, so that's 40 degrees right there. Let's call this, angle A. Let's call this angle B up here, so that'll be 60 degrees up there. And then side A is going to be boop, 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 this side over here, and that is going to be 4 inches. So what I want you to do, and this is what the instructions will say, it'll say solve the triangle. And what that means, y'all, is I just want you to find all of the other missing sides and angles. So we need to find angle C, we need to find side B, the length, and we need to find the length of side C. So let's get to it. What I'm going to do, let's see, well, angle C is very, very easy. We don't have to do much for that one. Do y'all remember all of the angles, the interior angles of a triangle, all add up to what? Does anybody remember? If you're saying 180 degrees, you are correct. I'm going to write that down as a quick remembrance. All interior angles of a triangle add up to 180 degrees. Okay, so that means if I know angle A is 40 and angle B is 60, I can just say, okay, so I know angle A plus angle B plus angle C, all of those add up to 180. That's 40 plus 60 plus C is 180. So those two together are 100. So C must equal 80 degrees. Please note how not to scale my triangle is at all. And that's totally fine. That's totally fine. So let me get back up here and say, all right, that's 80 degrees. Cool. Look at that. Oh my gosh, we have 1 out of 3 things done. So now let's go find out our side lengths. I am going to need to use the law of sines here. So let's get to it. I'm going to remind myself what the law of sines is. Remember, that is sine A over A equals sine B over B equals, oopsie, sine C over C. Okay, so let's just start with side B. You usually want to start with, actually we're going to start with side C. Sorry, I want you to get in the habit of starting with a bigger side. So since C is a bigger angle, we know that side C is going to be a bigger side. So let's start with side C. So I want to make sure and utilize that guy right there. Now, I don't know what side B is. So I am actually going to use sine of A over A and sine of C over C and set those equal to each other. Again, I'm not using sine B over B because I don't know what B is. So that would leave me with 2 unknowns since I don't know what C is either. So I'm not going to use that. So I'm just going to say, all right, so the sine of A over A equals the sine of C over C. Now A is 40 degrees and side A is 4 inches. So that means I need the sine of 40 degrees over 4 equals the sine of C, I know, is 80 degrees. 80 degrees. And I don't know what C is. That's what I'm solving for. Okay, y'all, do you remember in 5th grade when you talked about cross multiplication? Here is some cross multiplication. what we could do to solve for the c is we could multiply by c on both sides to get the c out of the bottom, and then divide everything out. But we're gonna use the shortcut cross multiplication. Some people have called this the heart method because if you draw a little, makes a little heart. I like to call it the dragonfly, because you can draw a little dragonfly with that. So what you're doing is you're taking, I'm doing a lot of talking and no mathing. I'm multiplying the two things that are diagonal from each other. So I'm going to say 4 times the sine of 80 degrees is equal to, and I'm going to do this side over here, c times the sine of 40 degrees, right? And now to get c by itself, all I need to do is divide both sides by the sine of 40 degrees. So divide both sides by the sine of 40 degrees. And I'm showing a lot of steps. You don't necessarily need to show this many steps. So 4 times the sine of 80 degrees divided by the sine of 40 degrees is equal to c. So if I was asking for an exact answer, you would stop right here. Please, 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 please do not go here and be like, oh my gosh, 80 divided by 40 is 2. So that is 4 times the sine of 2. That is so absolutely wrong. Don't do that. Please, please, please remember that this is one number altogether and this is one number altogether. I can't split those apart. Okay, that's not like sine times 80 degrees. That's the sine of 80 degrees. So be soups careful there. Pretty please. Okay, I want you to go ahead and find an exact answer. So this is where my super awesome calculator comes in handy. So I'm going to make sure I'm in degrees, which I am. And I'm going to say, okay, 4 times the sine of 80 is 3.9392311012. So I'm going to leave that there. And I'm just going to say, okay, divided by the sine of 40. So I'm not rounding. I'm not even going to write it down because I don't want to round in the middle of the problem. I want to go ahead and put all of that into my calculator and then round at the very end. So this says 6.1283554545. So I'm just going to say 6.128. And our unit, we know our unit of length is in inches. So that means my unit down here is going to be inches equals C. Booyah. Okay, so now that we have C, y'all, we still need to, since we're solving the triangle, we still need to go back and find side B. So now I'm going to use, and I'm actually going to use the glory of my iPad here and just scoot all that over like that. Oh my gosh, so amazing. And then we're going to do, now I'm going to put in sine B. So I'm going to say, okay, so sine A over A equals sine B over B. And technically you could have done this first. I just like to start with a bigger angle because that's going to come in handy when we do law of cosines later. So I want you to kind of have that habit in your brain. So this is going to be sine A was 40 degrees over 4. B was 60 degrees over B, like so. We're going to do some cross multiplication here. I'm going to draw my little dragonfly, boop, boop, or butterfly. I'm not sure. I don't know. Whatever floats your boat there. So I'm going to have 4 times the sine of 60 degrees equals B times the sine of 40 degrees. And then my exact answer, oopsie, sine twice, is going to be the sine of 60 degrees divided by the sine of 40 degrees is equal to B. I'm going to use my calculator here. So 4 times the sine of 60 equals divided by the sine of 40. And what I get here is 5.3 2.89 inches equals B. Okay, so for your final answers, y'all, what I would really, really, really love for you to do is just write all those unknowns in one separate box. So I'm going to say, all right, so my first unknown was angle C, and I figured out that angle C was 80 degrees. My second unknown was angle B right there. So angle B, or sorry, side B was 5.389 inches. And then side C was 6.128 inches. And then put a nice big box around those. That would be super rad if you could do it like that. Now I know, oh my gosh, it looks like a lot of work. It's really not. I went through a lot of steps to make sure and show you what everything was. So what I would like for you to do is pause, look back over the stuff you just wrote down. Hopefully you wrote all that down. Stand up, do a little stretch, maybe get a glass of water, touch your toes, maybe wiggle your hands a little bit, do some neck rolls, just get your blood flowing because we've been sitting for a while. Okay, guys, hopefully you were able to stand up and stretch a little bit. I did some shoulder rolls, so I'm feeling pretty good. Okay, so what I want to do now is I want to talk about solving non-right triangles with the ambiguous case, and this is using side-side angle triangles. Or SSA triangles. And what happens here with the ambiguous case, I don't know if you know ambi, like if you ever heard of ambidextrous, that means you can use either your right or your left hand, or ambivalent is another word that has that ambi beginning, which means like it's neither good, benevolent, or bad, malevolent. It's kind of in the middle or a little bit of both. We're not really sure. So ambiguous means we're not really certain about the solution, because what can happen is that we can have one solution, which is what we just had, that guy. We had one triangle that was possible with that information. We might have two solutions. We might have two possible triangles that could result from the information that we're given, or we might have no solution. So we might have a bunch of information that's given to us and we aren't even able to make a triangle with the information. So this is the ambiguous case, and it only happens with, excuse me, side-side angle triangles. So there's kind of a shortcutty way to figure out if you have one solution, two solutions, and no solutions if you have a side-side angle situation. If you want to look those up, those are on page 547 of your textbook. You do have to do a little bit of math, but you can kind of figure out which one of these you might be dealing with. I don't prefer to use those because it requires kind of a lot of memorization and getting into, I don't know, I don't like it. So what I'm going to do is I'm going to talk about how you can use the math, the actual law of cosines in math, to figure this out. So I'm going to do 3 quick examples, one of each of these, one solution, two solutions, no solutions, so you can see how you might be able to tell. So let's start with this one. Solve this triangle. So let's say side A equals 3 centimeters, side B equals 2 centimeters, and let's say angle A equals 40 degrees. Okay, let's go ahead and we want to sketch our triangle. And remember, it does not have to be anywhere close to drawn to scale or anything. I just want to visualize. So here's A, that's 40 degrees. Side A over here is 3. Let's make this angle B, which means boop, 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 boop. That's going to be side B down there. Let's make that C, which means it's going to be side C over there. Okay. So I want to be very, very clear here. You might be looking at this and say, oh, I have a side and a side, and I need to find this side. Let me just use the Pythagorean theorem. Please be careful. I know there are at least 4 of you out there thinking of that right now. Please be careful. I don't know which 4. I'm just going off to statistical probability here. but I know students have done this in the past. Y'all, Pythagorean theorem only works if you are working with a right triangle. This is not a right triangle, so be careful. Ten cuidado, por favor. We need to use the law of sines. That's right. So I want to figure out this angle, or sorry, that side, but I can't figure out that side until I figure out this angle. But I can't figure out this angle until I figure out this angle. So let's start with finding angle B. All right, so let's draw our law of sines real quick. So I'm gonna say sine A over A equals sine B over B. I'm gonna leave out the C's for now. I'm gonna come back for those. So I'm gonna say the sine of 40 degrees over 3 equals the sine of I don't know, whatever B is, over 2. Let's do our little cross multiplication dragonfly. And then we can say, all right, so 2 times the sine of 40 degrees equals 3 times the sine of B, which means 2 times the sine of 40 divided by 3 equals sine B. Okay, so now this should look a little bit familiar from the last unit. So this is where we are solving for an angle that we have the sine of, right? So I'm gonna go ahead and tell you, if you multiply this out, well, let's go ahead and multiply that out. I'm gonna use my calculator here. So 2 times the sine of 40 equals, oops, hang on, 2 times sine of 40 equals, and then divided by 3 equals. So I got 0.4, I don't know why you can't see it. Sometimes you can see it and sometimes you can't. It's on, I can see it. It doesn't matter. 0.4285250.731. Okay, there it is. Now you can see. I don't know. Okay, so what I need to do, that is obviously not on the unit circle. I don't know that angle. That sine does not show up on the unit circle that I'm aware of. So I need to use my inverse sine button. So I'm going to say, okay, second sine, and then instead of, I don't want to round that. So here's what I'm going to do. I'm going to say 0.429. I'm going to round it there, equals the sine of B. So the inverse sine of 0.429 equals B. But I'm not going to round it in my calculator. I rounded on my paper to write it down, but I'm not going to round in my calculator. So what I'm going to do here, I really wish you could see that. I don't know why you can't. It's bugging me. So I'm going to say the inverse sine of the answer. So it's not going to work. I typed in inverse sine of answer because I don't want to take the inverse sine of 0.429. I want the inverse sine of 0.4285250.731, right? So I'm showing all that. I'm going to hit enter. And this is what I get. 25.37399.394. So I'm just going to leave it 25.37 degrees equals B. Okay, pause. Let's think about what we just got. If we think about the unit circle, right? We just took the inverse sine. Sine is the y value. So we were just told that the inverse sine of this sine right here, the angle that I got was 25, and 25.37 degrees. So we're saying, all right, so that is the angle B right there, right? So that must have this y value. Let me actually make that a little bit gianter. The y value right here must be this value right there, right? That's what inverse sine means, right? I was like, hey, what angle has that particular sign, right? So since that's the case, I need to think to myself, what other angle has this sign right here, has that same y value? So if we think about this, this is a positive number, so I know it's got to be something that's going up, y'all. That's going to be on the other side of the unit circle. Let's put that right about there. So I know that whatever that angle is right there also is going to have the same sine, right? So how can I figure out what that angle is right there? What do y'all think? Anybody know? We've talked about this a little bit before, way back in the day. What I know for fact is that this angle is 25.37 degrees. So to find this whole angle, what I'm going to do is I'm just going to say, okay, 180 minus 25.37 degrees is, calculator please, 180 minus 25.37 is 154.63 degrees. Okay, so that means that my angle B, this is where it becomes the ambiguous case, my angle B could also possibly be 154.63 degrees. Okay, so let's think about this. Let's think about this for just a scotch. If my angle B was 154.63 degrees, look at my angle A. My angle A is 40 degrees. Y'all, that means that it is impossible for B to be 154 degrees. Can you tell me why? Hopefully, you are saying to yourself 154.63 plus 40 degrees boop, boop, is 194.63 degrees. That, my friends, is impossible. I cannot have that big of a measure in a triangle because triangles have a max of 180 degrees, right? Or not a max, that like a triangle is 180 degrees, right? Which means, y'all, I can't, that's impossible. So that means that this solution is going to be the only possible solution. So I know that this triangle is going to have only one solution. Okay, so I did my little test to figure out, hey, I have two possible angles for my sine, my inverse sine, but only one of those angles is going to be possible to work out. So then, using that guy, if I know that angle B is 25.37, let me go up here. Mixing up all my colors. I'm using a lot of different colors. 25.37 degrees, I can figure out C very easily by just saying, okay, so 180 minus 40 degrees minus 25.37 degrees is equal to C. So 180 minus 25.37 minus 40 degrees, that means 114.63. That's equal to C. And then what I'd love for you to do, now that we know all of our angles, we need to still find side C. I want you to pause this, go find side C. It should be pretty straightforward and easy. Use the law of sines, and then let me know what you get. Come back and check. I'm going to do it over here, but go check. Go do yours. Paused and you're back. I haven't done it yet. But here I go. So the sine of A, I don't know why I'm so tiny. Sine of A over A is sine of C over C. So the sine of 40 degrees was A over 3 equals the sine of 114.63 over C. I'm going to cross multiply. So I've got 3 times the sine of 114.63 degrees equals C times the sine of 40 degrees. Sorry, I should have done this while you were paused. I don't know why I didn't, but I didn't. I apologize. Talk amongst yourselves. Go, oh my gosh, y'all, let me tell you a story while I'm doing this. I just downloaded TikTok yesterday. Holy cow, the internet is so weird. Like, I don't even, the internet's so weird. Okay, so I got 4.24 equals C. Now again, I didn't round until the very, very end. So my unit of measurement is centimeters. So I'm going to make, remember my little box with all of my answers. So I'm going to say C equals 4.24 centimeters. Angle B equals 25.37 degrees. And angle C equals 114.63 degrees. I'm going to put a big box around that. Yay! One solution. Sorry, that took kind of a long time. Do yourself a favor, take a break again, glass of water. I got a lot of notes. I'm sorry, I got 2 more examples. Pause. I'll be here when you get back. In fact, I'm going to go take a break too. All right, y'all, I'm back. Here's our next example. We're going to solve this triangle. A equals 2, C equals 1, and angle C equals 50. Here's my little triangle. Let me label my sides, A, B, C, A, B, C. So this side is 2, this side is 1, and angle C is 50 degrees. So looking at that, I'm like, oh, I got a side, and an angle. So 2 sides next to each other, and then the angle that's not inside, so that's an SSA. So I know this must be ambiguous. So let's start by finding angle A, because that is across from a side that I know. So I know I'll be able to do that. So I'm going to say the sine of A over A equals the sine of C over C. I have to use C. I can't use B. I have to use C because those are the things that I know. So I'm going to say, all right, the sine of A over 2 equals the sine of 50 degrees over 1. I'm going to get in here. I'm going to do some cross multiplication, fraction on, no, not fraction on fraction action. Like that's not the same thing. I get carried away. It's just cross multiplication, not the same thing. And then, so I'm going to say 1 times sine A is just sine A equals 2 times the sine of 50 degrees. So sine A equals 2 times the sine of 50 degrees. It's 1.53. Wait a second. Check this out. So then if I wanted to get to A, I needed the inverse sine of 1.532088886. Y'all, this number right here, there's a problem. That number is greater than 1. So if you tried to take the inverse sine of 1.53, of course you're not going to be able to see my calculator because my computer's being a jerk. Maybe you can see it there. It says no. It says domain error. You can't do it. That's because sine doesn't go above 1 or below -1. So that means for this particular triangle, no solution. It's not going to work. So that just means, y'all, that these numbers together, those 2 side lengths and this angle, if those have to be the same, it's not going to make a triangle that works. I can't make a triangle that works. And please know, remember, this is not to scale at all. But this is basically saying if this has to be 50 degrees, this has to be 2, and this has to be 1, there's nothing I can put down here that will connect those lines together. So that's easy. It's a no solution situation. Huzzah. So we've done a 1 solution, a no solution. What do you think we're going to do next? Any thoughts? Any thoughts? If you're saying 2 solutions, you might be right, but I'm not going to give away the ending. We'll find out. Okay, so here we go. I'm going to say solve the triangle, please. Let's have A equals 6, B equal 8, and angle A equals 35 degrees. All right. So let's draw our little triangle sketch. Boop, boop. Let's say, okay, here's A, that's going to be 35 degrees, which means side A is 6. Let's say this is B. We don't know that, but we know that side B is 8. We don't know side C or angle C. So again, put in degrees on that. So we have a side, and an angle, so SSA. So I know it's an ambiguous case. I gotta be on the lookout. So here we go. Let's just start solving. Pardon me. So I'm going to say sine of A over A equals the sine of B over B. We're going to find that that angle B right there, and figure out if we can have more than one possible B. So here we go. We're going to have sine of 35 degrees over 6 equals sine of B. I don't know what that is, over 8. Let's do our little cross multiplication. So I have 8 times the sine of 35 degrees equals 6 times the sine, times the sine of B. Whoop. So 8 times the sine of 35 degrees divided by 6 equals the sine of B. Let's use our calculators. 8 times the sine of 35 equals, divided by 6 equals, so 0.765, let's say that, equals the sine of B, which means I need to do the inverse of that, of 765 to get to angle B, right? Notice I'm not rounding in my calculator. My calculator still has that super giant long number, and I'm going to say the inverse sine of the answer. There you go, like so. And let's see what that gets me. Boop, boop. Gets me 49.886. So I'm going to say 49.89 degrees is equal to angle B. Okay, pause, because we know we have a side-side angle situation, which means I need to check for the ambiguous case. So let's draw. Let's draw a possible situation. So 49, let's say that's 49. It's not the side length, Lindsay, right? It's the angle, So this right here, that's 49.89 degrees. So I know that there's going to be a possible angle over here on the other side too. And this, a green angle right there, how are we going to find that? So I know that this right there has got to be the same, 49.89, because I'm looking at the y values, right? Y values. So I'm going to say 180 degrees minus 49.89. So I'm taking this whole angle here, and Lindsay, right, let's draw something that makes sense. Goodness gracious, I'm trying to take shortcuts and I'm being confusing. I'm taking the whole 180 and I'm subtracting out this so that I can find this right there. That's what I want. So 180 minus 49.89, let's use my trusty calculator, is equal to 130.11. So I'm going to go over here, I'm going to say, or 130.11 degrees. Now let's go back and check. So angle A was 35 degrees. So I need to just double check. So 130.11 plus 35 equals 165.11 degrees. Am I still able to have angle C in there? Yes. So I have two possible situations, right? I have either angle B is 49.89 or I have angle B is 130.11. So I have two possible triangles that can happen, two possible side lengths and angles for angle C and side C that will make this triangle happen. And I'll do a little bit more explaining on this on the next notes. I just wanted to show you how to calculate it on these notes. So y'all, let's go ahead and calculate our two different triangles. So I'm going to say for angle C, boop, boop, I have 180 minus angle A was 35. Minus 35, let's use the first one right here. So B was 49.89, 49.89 equals 180 minus 35 minus 49.89, 95.11 degrees, or 180 minus 35 minus 100 and, oops, 30, oh, whoa, 130.11 minus 130.11 leaves angle C with 14.89. So those are my two possible angle C's. So this is angle B. This is angle C for that one. This is angle B. This is angle C for that one. So make sure you keep them together. Okay, so now let's use the law of sines to figure out side C. So this is just going to be regular C. So I know the sine of A. I always go back to the sine of A because that's the one we know for sure. So that way, if I made a mistake in calculating anything for B, I won't like calculate based on the wrong mistake. So I always go back to angle A. So 35 degrees over 6 is what I'm using. I'm going to calculate sine C. So sine of 35 degrees over 6 equals sine, and I'm going to use this angle right here, so 95.11, whoopsie, over C. Let me do my little cross multiplication. Boop, 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 boop. So 6 times 95, whoops, oh my gosh, I forgot the sign. 6 times the sine, that's quite important, of 95.11 degrees equals C times the sine of 35 degrees. So 6 sine 95. Oh my gosh, y'all, I cannot write things right now. Gracious. Divided by the sine of 35 degrees. That will get me to C. So let's do 6 times the sine of 95.11 equals, divided by the sine of 35 equals. So that's telling me that C is equal to 10.42. It's 419105, but we'll just round it off there. And then I'm going to do the exact same thing over here. I don't need to rewrite that since I already wrote it over there. So I'm just going to jump right in. Sine of 35 degrees over 6 equals the sine. This time I'm going to use this C right there. So sine of 14.89 degrees over C. Let me do my cross multiplication. So 6 times the sine of 14.89 degrees equals C times the sine of 35 degrees, which means 6 times the sine of 14.89 degrees divided by the sine of 35 degrees equals C. Let's use our trusty calculation machine. So the sine of 6 times the sine 14.89 equals, divided by the sine of 35 equals 2.69 equals C. Okay, so y'all, I have 2 separate answers, 2 separate possible triangles, and I want to keep them together kind of in their own little boxes, okay? So for this one, angle B was 49.89 degrees. Angle C was 95.11 degrees, and side C was 10.42. What was our units? We didn't have units. Okay, if I don't give you units, you don't have to put units at the bottom. So we're just going to leave it like that. That's my bad. I should have given you some units. So here, angle B was 130.11. Angle C is 14.89 degrees. Degrees, don't forget degrees. Those are units. And then C is 2.69. Make sure you keep those together. Don't like mix up, like put one C with the other C. That would be really bad. Okay, y'all, oh my gosh, that was so long. I apologize. I hope you took a lot of breaks. We will do a little bit more of this on the notes that I put out on Wednesday. But hopefully this gets you a good start with law of sines. Okay, hooray. I will talk to you soon. Remember to check in during class time if you have any questions, or send me an email. We'll make it work. All right, yay, math.